Okay, so we're going to get into the different components of railings, and we're going to be looking also at making railings that comply with Part 3 of the building code with respect to the extensions at the top and bottom of the stair, and we're going to be looking at making basically wall handrails. All of the handrails that you find in the architectural template are all self-supporting. So that is, they all have some sort of vertical support to hold up the handrail. So what we're going to look at is a wall-mounted handrail when you're putting a stair up against a wall, and no supports are required for underneath the railing. Now what I'm going to do here, we're looking at page 7, we're going to look through the different components of how a railing is defined, and here we go. So I am going to look at the handrail dash pipe railing style. Oh, what the heck? Why not? There we go. So I'm going to use the handrail pipe railing style here, and we're going to go through and look at the dialog box on page 7 for all the different components in the definition of a railing. So this is the type properties dialog box here for a railing, and I'll just stretch it out here so we've got a little bit more height. So starting from top to bottom, we have this first dialog box here, which Revit calls non-continuous rails. Now, if you folks can see the blue horizontal geometry here, those are called the so-called non-continuous rails. The reason that Revit calls them non-continuous is that Revit makes no promises about whether these horizontal elements will remain connected to each other when a stair makes a tight corner in a stairway landing. So let's just look at what that might look at in terms of a problem here. So I'm just going to do a really, really tight stair. Folks, I found out, I had to Google it, and if you folks remember earlier, I was having my stair and it was always forgetting to add a riser at the end of each flight, and I was getting a little fried. When you're creating a new stair, in the properties palette there's a drop-down menu here, and it allows you to choose between the properties of the stairs, we're working on it right now, or the properties of the floor plan that we're working on right now, but there's also this, new stairs, runs. Now if I had gone into this dialog box earlier and dropped down to this new stairs runs selection, I'd be presented with this. And I could have gone in and rechecked the box here, end with riser, and my sanity level would have just gone up like by 50%. So that's just something to keep in mind. If Revit is failing to create that end riser, you can just go in here to new stairs runs, check the box, and you'll be fine. So I'm going to make a tight stair here now, and we're going to see how we run out of room with those railings, and how they end up not being continuous. Now this isn't really good practice to slap up your stairs right side by each. In some cases, you know, you're trying to design to a minimal size, and this is what you have to do. So let's look and see what we get. So we look at this in 3D. And I'm going to use that handrail pipe railing style here. So if we zoom in on this railing here, what they're saying is that, and you can see the problem here, really good example. Now, if you folks look at this top horizontal, it comes down the upper flight, gets down here, and then where it terminates, it's kind of running into the handrail on the top of the railing. So what's happening is that there's discontinuity. Those horizontal guards are not able to be meeting up. And that's, of course, because we've got this gooseneck that's happening here. So when we look at this dialog box here for our stairs properties, when it says non-continuous, that's what it means. And in this dialog box, you specify the heights that you want each one of those horizontal guards placed at. And then in here, you could choose their profile and place them at different heights. And if you want them offset horizontally from that pink line that you draw across in plan, that's what the offset value is. So here, if you want to have different shapes or a different size for those horizontals, you'd need to define that in the profiles folder first. So how many of you are aware of the new, like to this last building code, the new changes with guards and railings? Great news for designers. Basically, these kinds of horizontal guards, until the last version of the building code, weren't allowed in BC, but now they are. And the problem was that Canadian children before the last version of the building code were stupid. They were. Because what happened was that a Canadian toddler would come up to one of these guards and it would immediately climb up them and tumble over to their death. But with the advent of the latest building code, that no longer happens. As long as the difference in height between the top of the railing and down below is not more than 13'4". So if it's less than that, your toddler will survive. It's good news. We can now have horizontal guards in our railings. Now, if you want to do something like a stainless steel cable, let's look at how we make that happen in our railings design. So what we need to do is come up with a smaller profile, say 1/4 inch, right? That looks like that cable is being drawn on the screen. So we're going to look at that right now here. So hit OK. And what we're going to do is we have to exit the stairs or the railings dialog box here, and we have to roll on down to the profile folder and find the circular handrail entry. So inside the circular handrail folder, find the 1 inch profile size, right click and duplicate it and rename it to be 1/4 inch. Now, of course, we need to change the size of the profile so that it is 1/4 inch as well. So just double click it. And where it says diameter here, we go to 1/4 inch. So there we go. Now that we've created that 1/4 inch profile, we have to go back and redefine our railings design to incorporate that new size. So just go back and click on your railing and go into its type properties. Inside the railings type properties, we've got to go and find the rail structure dialog box here and switch all 5 of these to be the 1/4 inch. Pro tip, you can actually put your cursor inside one of these cells, select it all, and Control C. Then you can go down to the next, and you can just have to Control V. Actually, have to go Control A, Control V. Come on. There, Control V. It's not working. There we go. What have I done? Control C. There we go. Okay, so now they are all going to be 1/4 inch. Now, ignoring the fact that we need one right here, of course, to create a, we'll talk about how we can sort that out in a moment. But there we go. So now we've got our stainless steel cables, and if you wanted to make them larger or smaller to suit, you'd be able to do that now. Now, this top member here is not part of the so-called non-continuous rails. So that top piece there, which is the top element of our railings design, is not from rail structure. We'll jump down and look at that next. It's what's called the top rail. So generally speaking, the horizontal elements of your railings design are either from the non-continuous rails, or they are from the top rail or handrail sections of your railings type properties. What I'm going to do now is just do a little sketch on the board to talk about what top rail and handrail are meant to do. Okay, so the top rail feature of your railing is meant to be a non-graspable finish element to the top of your railing. So top rail, generally speaking, non-graspable, but they're at the top of a railing. So if you don't need a handrail, but you still want something that tops out your railing as either a finish element or protecting the user, say from a glass, if you had a glass panel that's at the top of your railing, and you want to protect someone from, you know, if you've got a piece of glass and it doesn't have a chamfer at the top, and you just want something that caps off the top of that railing's design, that's a really ideal use of the top rail. Now, what's the difference between the top rail and the rail structure? Well, what the top rail is that Revit tries to make it continuous no matter what path the railing takes down a set of stairs. So that's why this is called non-continuous, and Revit is kind of hinting that this is going to be more continuous, and that's the case. Also, too, you can define its height separately from the rest of the railing's design. So if you wanted to, you could have your glass panel top out at some particular height above the floor, and then you could have your top rail sit above that at whatever height that you choose. Now, your top rail and your handrail, these are plugins. So these are defined independently of your railing's type properties. So all this stuff up here is part of this railing's definition. But these things get plugged in from outside, and the top rail and handrail definitions can be used in a whole bunch of different railing styles in your project. So we'll see how top rail, this circular 1.5 inch, it's in its own folder in the project browser, and you can use this top rail in as many different railing styles that you've got on the go as you want. Same with the handrails. Now, handrails, these are meant to be the graspable part of your stair, the thing that you put your hand on. So with these handrails, what they would then be is the part of your railing's definition that people grab onto on their way up the stair. Why is there two of them? Well, if you have a situation where you had like an exterior stair, say going up some public steps to the outside of the building, you can have a different profile on one side rather than the other. Now you'll see that with these handrails here, with the position, you can have left and right. I think it calls it both. So in this case, we could have the same profile on both sides. And you could do that with just one of the handrail settings here. So with handrail 1, you can have position left, I think it's both. You have positions both and then you could have this graspable handrail, same profile, on both sides of your railing. But if you needed to have that sort of barrier-friendly or barrier-free handrail on the other side, you could, for handrail 2, you know, this one could be positioned as left, this position on this one is right, and the type here could be, you know, circular, and this one could be the, you know, barrier-free, which isn't defined yet. So you could have 2 different profiles on your railing. So this could be handrail 1 here, this one could be handrail 2, and this one could be your top rail. So Revit can have all these different features that you can plug in to make your railing work. So that's what's going on. So we're going to look at each of these in sequence here. Okay, so let's go over to the next page here. So we've talked about our rails non-continuous. So now what I'll just do here is I'm going to go into the project browser and talk about how things are laid out in the railings folder. And it is a bit ugly. I go over this in the intro course, but I'm going over it again here just so you folks are quite clear on how Revit organizes these things. So in the project browser, when you go into the railings folder, it does not immediately show you all the different railing styles that you've defined in your project. If you go into any of the other folders, like walls, you can expand it and you'll see basic wall, and then you can expand that, and you can see all the different wall types that you've defined in your project so far. But now with railings. With railings, when you come into this folder, it lists all the balusters right off the bat. So the vertical bits. So here you've got round balusters and square balusters and glass balusters, and just lists them in with all the other important stuff that's part of how we define our railings and how we organize railings in our project. So if you look on page 8 of the notes, there's a folder here called handrail type. So that's where you define all the different kinds of graspable handrails that will be part of your railing style definition. If I expand it here. So if you folks remember, we saw that circular 1.5 inches. And you'll see here that there's actually a couple of wall-mounted handrails that are here ready to go if we decide to use them in one of our railing styles. So the deal is that these 2 handrail types that you see here are not being seen in the model because they haven't been called out by one of the railing types. So if you have a railing style and you want to use a wall-mounted handrail, then you've got to pull it, you've got to invoke it, you've got to use it. Right now, none of the railing styles are using these 2 handrail types, which is not being used. So we'll show how to use them in a minute. So there's a folder for the handrail types. There's a folder for the top rail types. So those are kind of important. And then, inexplicably, there's a folder called railing. And it is inside this folder where we will see all of the railing styles that have been defined. So you kind of have to go back, go into one folder deeper to see all these different railing styles. So what we're going to do is we're going to take one of these railing styles and we're going to duplicate it and make a wall-mounted handrail style. We'll do that in a few moments. In fact, we're going to do that pretty quick here. So on to page 9. This is something just for your reference. I'm going to not go over that because that's just really for your information so you know how to use it. The rail join tool, that's something that you can work out yourself as well down towards the bottom of page 9. What I'm going to do right now is walk you folks through the process of creating a railing that only has a wall-mounted railing. So there's no supports for it. So it'll be like this rail is just floating in space, with the idea being that this stair is adjacent to a wall. The first thing that we need to do is create a railing style that is called wall-mounted handrail. So I'm going to take the guardrail guardrail rectangular. I'm going to take this one, guardrail rectangular. So select that railing style in the project browser, right click, and we're going to duplicate it. So in the railings folder, go down to railing, find guardrail rectangular, right click, and duplicate it. So the new style here, we're going to rename this. So find the guardrail rectangular 2, just right click on it and choose rename. And we'll call this handrail wall mounted. So what we need to do now is define this railing style so that the only thing it has in it is a handrail type defined. So just double click on it. So here's the type properties of our handrail wall mounted. So now, do we need a top rail? No. You can uncheck the box. Now, what about our non-continuous rails? There aren't any, so that's good, and we don't need any. So to create a wall-mounted railing, the only thing we need is a handrail definition that's been called up. So for our balusters here, make sure there's none of those. So in this dialog box here, what we need to do is go up to the very top here and specify that the baluster family that's used is, at the top of the list, none. So no baluster being used up here in the main pattern. And then down at the bottom, same thing. No balusters used for the posts. So really what we're creating here is otherwise, this is an empty railing definition. There's not going to be anything inside it except for our handrail. So when you want to make a wall-mounted handrail, you need to put it in the left position. Otherwise your rail will be inverted, or not inverted, it'll be reversed. So the supports for the railing will be into the stair instead of against the wall. So we're using handrail 1, position left, circular 1.5 inches. There we go. That's it. So now, if you've got a stair here, click one of the railings in your stair and switch it for this newly created handrail wall mounted. And there we go. So now you can see our railing doesn't have any supports. Now, what if we would like this railing to show some support so it looks like it's, you know, connected to the wall and not just elevating magically in space? Well, this railing style inside it, right, it's using this circular 1.5 inch handrail type. So of course this handrail type is in its own folder in the project browser. It's right here, circular 1.5 inch. So I'm just going to hit OK. And I'm going to go back and double click on the circular 1.5 inch. And now we're going to go through and talk about the different features of these handrails. So these handrails only appear in your project if you've got a railing style that calls up one of these in the handrail section of that stairs, or of that railing's type properties, right? So here we look at the properties of a handrail. We can specify things like the clearance behind the railing, so the distance between the center line of the rail and the edge of the stair. So here we've got 2¼ inches. We can specify its height. either above the floor or above the nosing line. So you're 3 feet above the nosing line above the stair, that's great. Here we can specify the profile, so circular 1.5 inches is absolutely ideal from building code perspective, so that's awesome. And now what we can do down here, there is a supports section. So what you can do in here is you could specify the support family that's being used. Now these are special families that have the little, you know, escutcheon plate that's on the wall with the little mounting arm that comes out. And you can look at the one that's in the out of the box template and make modifications to it if you wanted a different look. So right now, we don't have any supports, so let's put one in. So there's one that's provided in the architectural template. And you can specify if you want to align it with the posts. Of course, we don't have any. So instead, we'll choose a fixed distance or a maximum spacing between them. So I'll say a maximum distance of 4 feet. If you choose the fixed distance option, then there's a justification mode that kicks into play here. So if you want to center justify your supports so that they're placed every 4 feet along the length of railing, that will kind of give you a good spacing of these things. So go ahead and hit OK. And now you'll see that your supports are being added along the edge of your railing. So again, your handrail definition is being plugged into your railings type properties. So this circular 1.5 inch handrail is like a plug-in that goes into your railing style. And again, you want the left position because if you choose right, then your supports are facing the wrong way. So generally speaking, when you're putting a handrail on a stair, you put it in the left position. If this railing was going to be used on a wide set of exterior public stairs, you could of course put this handrail into the left and right positions here, and there you can see it would provide a pair of handrails that would be placed. Okay, so that is the supports. What about the 1 foot extension of our handrails as specified by part 3? So if you need a railing that extends at the top and bottom of the stair, that is also baked into your handrails definition. And it's simply by specifying an extension at the beginning and end of the stair. So just put in 1 foot for both, and that's all it takes. And you've got your extensions at the top and bottom of the stair. Now when you're looking at the handrails definition, it's a little deceiving because it says extension style is none. Well, if I have 1 foot as a length but I have no extension, why is it creating an extension? Well, the extension style here of none just means that the stair railing, or that the handrail extends. There is a wall extension style, which means that this thing will return back to the wall. It'll do a little dog leg, like that. And you can decide if you want that return to be placed there or not. You do see it in plan, so you can decide graphically if that's what you want. I typically don't bother, so in my handrails definitions, I just leave the extension style top and bottom set to none. Graphically, it's most straightforward, and you know, you can still put your dimensions on there for the extension of your railings, and that deals with your code compliance that's being required. Okay, so that is page 10 out of the way. Page 11 here, we're going to move on and talk about balusters now. Now, balusters are the uprights in your stairs design. And uprights come in 3 flavors, top of page 11. And there are templates that Revit provides for each of these cases. I am going to, at this point here, I'm going to open up a file on our session 9 folder here, and I'm going to call it, no, it's Revit Railings, that's the one. So this will allow us to talk about the different kinds of balusters and what their purpose is. Okay, the first kind of baluster is the most commonly used baluster, and it's your simple vertical, your picket. Whether it's a wooden turned baluster like the ones that you see here, or if it's a metal one that's got a more interesting shape like the one behind it. Those are considered simple balusters. They're just the simple pickets. The second kind of baluster that we see is a newel post. So on a heavy wood railing, like you can see that big gray post at the end of that railing's design, that's called a baluster post. So both of them are considered to be limited in length. So both the picket style baluster and the post style baluster are not usually 4 feet long. They're usually, fairly tidy in their dimensions. They're not very large. Finally, we have the panel type baluster. So these are the longer ones, and they typically are glass or some other configuration of glass and or metal. They tend to be longer in length and placed less frequently. Now, regardless of whether it's a picket, post, or a panel baluster, they are still always placed on a center-to-center basis. So we'll talk about that again in a moment. Now I'm going to skip this simple baluster process here on the middle of page 11 because I just want to get into talking about how balusters are created and how they're defined and how you can build them. Now I'm going back to my project here where we created that wall-mounted handrail moments ago. And at the bottom of page 11, you folks can see that this is the baluster round family. So I'm going to find the baluster round in the architectural template. I'm just going to right-click and edit it. Now we're in the 3D view here. Let's go to an elevation view. Okay, so here is the, oop, that's too small size, inch and a half. There we go. Okay. I'll turn on shading here. So there is the baluster, a simple round baluster. And this is based on a template. And we'll look at those templates in a second. So this is based on an out-of-the-box template that you folks can see, and I'll show it to you in a second. The only thing that they've done that's a little different here is that there's a void in this zone here, and there's a void in this top zone here that cuts off this geometry. And this geometry is just a circular extrusion. It's extruded in plan upwards to create this picket. The voids at the top and the bottom of this family trim off this picket so that when you place it in your railings design, if you've got a non-continuous rail at the bottom and you want this picket to die into it, it'll get trimmed at this reference plane. So this is the defined bottom of the picket from the balusters box. So you don't have to think about it. You just model your geometry in here, you put your void in top and bottom, trim it off, and it just works. Rivet adjusts the angle of the reference planes here from whatever angle your stair is going at, so you don't have to worry about it. So these things are actually pretty straightforward to set up. So what I'm going to do now is look at the 3 templates for balusters. So if you folks go to the File menu and you choose, you hover over New. So File menu, hover over New, and choose Family. In this dialog box, there's the 3 different templates at the top. So there's your baluster for creating your everyday pickets, the vertical elements of your railing. And it's very similar to the one that we were just looking at seconds ago, only it doesn't have the voids in it. So you just have to add them. If you were wanting to make your own custom shape of a baluster, I actually wouldn't start with the template. I would go in and instead modify the out-of-the-box, round baluster or square one, and build my new geometry inside it, and then save as, because it's already got the voids in there, which are super handy. The next family template to talk about here is the post template. This one is even simpler because it does not pay attention to the angle of your stairs. So in the case of, which one is it here? This post right here. If you put this baluster post on a stair, it doesn't get trimmed. It just sits there. So it's meant to be at the top and bottom of your stair. And of course it's meant to be part of the horizontal restraining of the stair so that your railings have something strong to die into at the top and bottom of a flight of stairs. So that's your posts. Very straightforward to build, so just build it out of whatever you want and load it into your project. Now, the last baluster template to look at, and we're going to work with this in a few moments, is the panel template. So this template is to define some sort of design for your railing that has a greater width. So in this case, it's 2 feet wide. Now it's probably not 2 feet thick, right? It's probably just 1 inch thick, because you don't want your railing, you don't want this panel protruding into the stairs. So they tend to be thin and wide. So for something like a piece of glass with some elements to hold the glass in place, you would model those things here at the corners. And once the panel is done, load it into your project, and then you've got this width parameter here that will allow the panel to stretch in size as required when you're defining the railing inside the project. So flip over to page 12, and there you can see the baluster with the glass clips, and there's a whole bunch of length parameters in there, dimensions, that allow you to change where those clips are located with respect to the corners of the glass. So these baluster panel families are a little bit more fussy to set up and takes a little bit more work. So there's some notes in there about the width of the family and how the width parameter works with respect to its use in a project. Now we are going to build our own panel family template here, and we'll do it together, and I'll do it live on the screen here with you. We're going to need a profile family from our session 9 folder. It's just called Box. So I would suggest that you go to the Share Out folder for tonight and copy the entire session 9 folder to your flash drive or wherever you're storing your content for this course. I have it on my desktop here, so I've got my session 9 folder with everything that we'll need for this next little exercise, which is just the one file. So I'll give you folks 30 seconds here to get set up, and then we will continue. All right. So it says create a new family based on the baluster template. Ensure that you are in a left or right elevation view. By default, it kicks you into the left elevation view. Okay, step 2, using reference lines or model lines and visible lines from the subcategory menu, create a diamond pattern as shown. So let's do it. I'm going to use model lines. And now Revit asks which reference plane I need to be in, and it's center, left, right. Now, how do you know? Well, if I chose center, front, back, oh, it's not going to show it here. So here I'll, this is the baluster panel. So if you're starting from scratch here, so you go to File, New, Family, and it's the baluster panel. Okay, so now we're adding a model line, and it's asking for a plane. It's going to be the left-right plane. And this means that we're drawing right on the plane that's at the center line of this panel when looking at it perpendicularly from the view that we're looking at it right now. So we're placing model lines, but instead of using this balusters subcategory, we're switching to invisible lines. And the reason we're doing this is that once these lines are loaded into a project, they will not be seen. These lines are just meant to be the center of a sweep that we're going to draw from corner to corner. So we're making sort of one of those sort of Yaletown style diamond shaped balusters to use as a guard. So invisible lines, and we're going to go from the intersection here. Make sure you've got the intersection snap happening. And I'm going to turn off the chain mode, and the reason that we're doing this is so that we can see the padlock options to lock the alignment of this line at each end. If the chain mode was checked, the moment we finish the line, Revit starts drawing the next line and hides those padlocks from us. So it's nice to just have that box unchecked. So we're going from the intersection here. There's our first click, and then go up and make sure that you are in fact connecting to that intersection at the other corner. Henry, I think we need some help here. So once you go from corner to corner, you should see padlocks. Lock any padlock that you see. So again, I'm using the model line, and I'm using invisible lines as a subcategory, and I have unchecked the chain mode. So now I'm drawing it from the other corner. So from this corner here, again, make sure that there's an intersection snap on your screen, and then go to the other corner. Again, make sure you've got that intersection snap happening. When you see padlocks, click them. Okay, that is what you are after. Anybody need a hand? And then you can So what these are, these two invisible lines, are the sweep paths for building the diamond. So Henry, they go from this corner here, up to that corner, and this corner, to this corner. And chain has to be turned off up here, so we can see those padlocks as they appear. So now that we have the sweep paths drawn, we're going to do some sweeps. Now, we could draw the cross-sectional profile each time on our own, but we're going to save ourselves a step. So what you folks need to do is we're going to go to the Insert tab here, and we're going to choose Load Family. Insert tab, Load Family. And now what we're going to do is go into the Session 9 folder and find the box family. That's in the Share Out folder. Grab the box family and load it into this one. So give you a couple seconds to get that wrapped up. All right, so now that we've got this box family loaded, we're going to do the sweep. So from the Create tab, find the sweep tool. Sweep. So, in this case now, we're not going to draw the path, we're going to pick the path. So, the reason that I drew these two invisible lines before I did the sweep is that I found that those lines will very reliably lock to the corners of these reference planes, the intersection points of these reference planes, than if I draw the sweep using the sketch path tool. So right now I could use sketchpath and I could draw those lines myself, and probably 9 times out of 10 everything would be fine. But I just had situations where I drew using sketchpath, so those invisible lines weren't there, and I just drew the lines and I did the sweep. And then sometimes when my angle of my railing would change on a stair, the lines would go completely to the corners. And I was like, what the heck? So I thought, oh well, I'll draw them with lines first because I know I could use the pick path option, and that, who knows? It just seems to work every time. So that's what we like, something that works every time. So pick path, pick one of them, just one. And so there's the path for our sweep. You folks can see this dashed green line here. That is the profile plane. So that's where the cross-sectional profile of a sweep will be drawn. So that's it, we're done. Green check mark. And now, rather than having to go to edit profile and draw the cross-sectional profile ourselves, it's going to be here in the menu. So you should see box in the drop-down menu at the top. And so once that's done, you can hit the green check mark again, and you should have a straight line sweep. And so now we just do that for the other side. Create, sweep, and then we choose pick path again. Pick the line going in the other direction. So you'll see that pink line there. So the pick path is done. We can hit the green check mark. And now again, we're going to pick box from the menu at the top, and we can finish. So when you go to look at this thing in 3D, this is what you should see. You'll see a couple of straight bits of geometry there, kind of a cruciform pattern. So we're at step 5 on page 12. So when we're looking at this X-shaped piece of metal from the outside, and by the way, if you're wondering what this is going to look like, it's going to look like this. So you'll have your baluster, you'll have the top of the railing here, and you'll have your balusters here, and it's just going to do this. It's just going to create a nice little X-shaped pattern with our railing. That's all we want it to do. So what we want when we're looking at this thing, so here at a larger scale, we don't want to see the lines crisscrossing each other in the middle like is happening right now. Right? That's no good. So to solve that, we just merge the two geometries together using join geometry. So use the join geometry tool and pick the two sweeps, and you'll see that the lines in the middle here go away. Now what we want to do is give ourselves the ability to change the material of these things. So it doesn't matter which one of these sweeps, just hit escape twice so you're out of the join geometry command. Pick one of the sweeps, and we need to add a material parameter. So where the material parameter is, when you've got one of these sweeps selected, it doesn't matter which one, by the way, because they're merged. So when you join geometry, two solids together in a family, if you give a material parameter to one of the solids, it automatically gives it to the other. Little gray box on the side. And we need to add a new material parameter, and we're calling this baluster material. Baluster material. Step 6 on page 12. Okie doke, that's it. Okay, okay. And step 7, save the family as baluster diamond. So file, save as, family. I'll throw this baluster diamond. Okie dokie. So looking at page 13, this is the baluster dialog box that's part of a railing style. So when we are doing our own railing definition, it's always based on a center-to-center placement of all of the balusters, whether it's a simple baluster, a post baluster, or a panel. So we're going to go look at the baluster placement dialog box. It's kind of an ugly Excel dialog box from hell. But we have our start for the pattern, and then we have our end of the pattern. So here's our starting line. So typically with a panel, or with a pattern, we'll have a baluster that's placed at the beginning. And then we've got to come some distance, and so now here we're going to put in our diamond baluster. So this diamond baluster, instead of say starting from the beginning of the baluster and just saying, you know, it starts at 0, all of our balusters, whether they're panels, posts, or pickets, is always to the center line of the particular baluster that we're using. So we need that center to center distance. And so now this will lay out our baluster. Now to get to the end of the motif that repeats, and the way it's going to work for this design is we have the one picket on the one end, and then our X baluster. This is what repeats. And then we just keep repeating picket, X, picket, X, picket, X, for as long as the post goes. So picket, X, picket, X. That's our pattern. So to finish the pattern, we've got to tell Revit where it has to go to get to the end of the pattern. So our end is going to be here. And we'll see that in a second. So it's always center line to center line of everything. So we start somewhere, put in our next part of the pattern, and then we've got to get to the point where it ends after we've gotten to the center line of the last item in the pattern. So let's do it. All right, so in our project here, we're going to start with the handrail rectangular, so I'm just going to close this file down here. And if you folks want to start with a new architectural template, so looking at page 13 here, final assignment for the night, start a new project using the architectural template. Open up your baluster diamond family, so it should be in the file menu there waiting for you. So once you've opened up the architectural template, go into the file menu and find your baluster diamond. It should be in there. And this is it. Okay, so step 2, open your baluster diamond family and load the family into the project. Now you'll notice there's 2 options up here at the top, load into the project or load into the project and close. I'm going to choose load and close, so it'll just, I won't be looking at this tab anymore. So that new baluster is in this project. Step 2, in the project browser, find the baluster. So under families, under railings, and it'll be right here immediately under the railings folder. There it is, baluster diamond, baluster diamond. So it says, double click its child entry, so that's what I've got right here. To enter the family types dialog box. Once there, edit the width parameter at the bottom here to be 4 feet. So what this is doing is making that diamond shape, instead of being 2 feet wide, we're making it 4 feet wide. So we need half the number of vertical balusters to do our railings design. So looks like y'all are mostly here, so that's great. So the baluster here is ready to go, and I'll rename it here and I'll call it 4 foot, so that we know that it's a 4 foot wide size that we're making for this baluster. There we go. Okay, start a new railing. And choose the handrail rectangular, which is already selected. Duplicate it. So edit type, and then duplicate, and we're calling it diamond baluster railing. Diamond baluster railing. Okie dokie. Then it says, step 3. Uncheck top rail so that it's not added. So right here, folks, use top rail. Bye-bye. In the rail structure non-continuous dialog box up here, we have no rails. Have a rail called top at 42 inches and a rail called bottom at 4 inches. So what we need to do is down at the bottom here, see it says insert? We're adding new horizontal. So insert, this one up here, we'll call it top. And it says it wants it at 42 inches. 42 inches. Use a rectangular 2x2 profile. And it's at 4 inches, okay. 4 inches. There you go, folks. That is what you want to see. 2 rails, one called bottom, one called top. Top's at 3'6", bottom's at 4 inches, offset is 0, and for both of them, they're using a rectangular profile 2x2. On to page 14. Okay, so now we're doing the baluster placement, so we're into the baluster dialog here. So here we go. So, for our baluster family here, we're going to go and find our diamond baluster 4 foot. Now, how did we get here? It's the next dialog down, baluster placement. So in the top part here in row number 2, change the baluster family to our baluster diamond, 4 feet. And look where it says base, right here. Sorry that the writing is so small on the screen. So the base for this one needs to be bottom. The top of our diamond baluster needs to be the top rail. So Revit is getting these names here from the rails. So when you guys are making your own railing design, typically you have to define the rails first, so you can define the tops and bottoms of your balusters if your balusters are going to be trimmed by some horizontal element in your design. So baluster, bottom, top, distance from previous, 2 feet. So we're starting from the beginning of our railings design. We're coming over 2 feet because that's the center of a 4 foot wide panel. So distance from previous, 2 feet. There we go. Now we need to add another row. So what you do is put your cursor on the 2 over on the left hand side and choose duplicate. But in this case we want to have the square baluster. It says 1 inch in there. I'm going to use the 2 inch because the horizontals are 2 inch, so it'll look weird if there's a 1 inch vertical and you have 2 inch horizontals. Now look at the difference here though. The baluster square goes from base equals host up to the top. And it also is 2 foot from previous. So what's happening is we're actually doing this opposite to how I have it written here. So what we're really doing is we're starting the pattern. We're coming over 2 feet, putting in our 4 foot wide diamond. Then, that's step 1. Step 2 is we're coming over another 2 feet, and now we're putting in our picket. And the reason we're doing it this way is because we've got our posts at the bottom. So with our posts in any railing, so this is the start and this is the finish. This is your start post here. This is your corner post. So anytime that you have a corner in your railing, it's called a corner post. And then at the end, you've got your end post. So what's happening in our pattern is we've got our start post, that's already a given. And then we get a diamond, and then our picket, diamond, picket, until we get to the end. And then finally, we've got our end post. So you're probably wondering, well, is Revit going to put the other baluster that's in my pattern in the same place as my end post here? No. Revit knows not to put the two of them in at the same place. Okay. So down at the bottom here, I'm making all of these baluster square 2-inch as well. Pay attention here. You'll notice that for all of these posts at the bottom, the base has been sorted, but the top is blank. And the reason it's blank is because probably when we removed the top rail, it had the top rail listed in here. We've deleted the top rail, so there's no top rail anymore. So we just got to switch it so it uses our top non-continuous rail. Now you folks will also see that there is a space value here. Space. And it really only matters for your start and end post. And what it means is, if you had, let's say you want to do a wooden fence rail like you do in your backyard, and you have a 4x4 post, right? So you got a 4-inch post, and of course it's mounted on the center line, right? So if you wanted to have like a 2x6 top cap on your post, and that would be one of your non-continuous rails, that 2x6 top cap will start right at the center line of your post. Well, now you're going to have the post that's not underneath this rail. So what do? Well, we can push this corner post or the start post forwards by changing the space setting. So if it's a 4-inch post, we need to give it space equals 2-inch, half the width of the post. So here we've got 2-inch balusters that we're putting in, so our space value needs to be 1 inch for the first one, and minus 1 inch for the last one. So basically 1 inch pushes it forward, negative pushes it backwards. So in this case now, our posts will both be tucked underneath any rails that are on top. So that's what the space value does. All right. So let's hit OK here. And we should be good to go. So now let's just draw a line across the screen here and see what we got. All right, that's what you folks should have. Again, if you don't have that sorted, I will come and see you after we are done here for tonight. There's some more information in the notes here about the glass handrails there. Those are also provided in tonight's folder, so you can see how those were done on page 15. Page 16 was the wall-mounted handrail that we did earlier, so you guys have that for reference. And then there's some other stuff about handrails and making an airfoil shape on the final page of the notes, which you folks need to have handed in for next week, because there's lots of different applications for railings that you wouldn't think of. So for doing sunshades over windows to provide solar radiation protection for your outside glazing, we've used railings in the past to create those sunshades on the building. So instead of the balusters going vertically, the balusters go horizontally, and you'll see this, it's provided in the share out folder. So that's another exercise that you folks need to hand in next week as well. Okay, so I'm going to end the recording here, and if you folks have any questions, we'll answer those for you, and that's it for tonight.